when we've been dealing, folks, we've been taking right here representative particles, and we've been moving this way to mole, right? We've been taking mole, we've been going this way to representative particles. We haven't did a two-step problem where I went moles, representative particles, and then found some atoms in another step. Or I could have gone atoms to representative particles over to moles. So, we've been doing a bunch of different types of these problems. What we're going to do today is we're going to learn a new one. And it's going to be dealing with that top one where I'm going from moles up to mass. Moles to mass, I could go mass back down to moles. Okay. So, I need to have a conversion factor. Well, we've already talked about the conversion factor because we discussed the molar mass to start out this unit, right? We said that the molar mass was simply the mass of 1 mole of a substance. So Avogadro's number of particles has a mass. Correct? So we said, for instance, we said that the mass, the molar mass of 1 mole of carbon was 12.0107. Where did I get that 12.0107? Where did I get that number? I didn't just make it up. Where did it come from? That's the atomic weight on the periodic table. So take out your periodic tables. We're going to be using those. So if I were going to figure out the molar mass of sodium chloride, what would I need to do? Calculate the mass of sodium with the mass of chloride, right? We've done molar mass. Now, how are we going to use that on our conversion factors? I'm going to set up my conversion box right here. So, as I'm going from mole to mass, what do I want to cancel in the denominator? Mole. So 1 mole will go on the bottom there. What will go on the top? The molar mass. Now, why didn't I put a specific number like I did with Avogadro's number? They're all changing, right? The molar mass changes depending on what substance I have. So likewise, if I'm going the opposite way, what's my conversion factor going to be here? What's my conversion factor here? As I'm going from mass, right here, down to mole. Okay? 1 mole over molar mass. Now let's jump right in. My question is, how many moles are in 8.00 grams of iron-free oxide? 12. The first thing I'm going to do is I'm going to write what is given to me, 8 grams of iron-free oxide. What is my formula for iron-free oxide? Fe2O3. Does everybody agree with that? Okay. Once again, nomenclature. I told you it was very important to be able to write formulas. If you can't write formulas, you can't get molar masses. Now, what I would like for you to do is to calculate the molar mass of iron 3 oxide right now. All right, what did we get for our molar mass of iron 3 oxide? Somebody give me a hand. Okay. Carly, what'd you get? That was close, but that's not what I got. I got a little bit higher. Everybody get 159? What'd you get, Vance? Maybe I wrote down the wrong number. Okay. What'd you get? 159,688.2. Okay. I'll go with it. I must have wrote down the wrong number when I wrote it down last time I did it. So, we're going to take that molar mass. Let's go back to our flux capacitor. Where are we at right now with our 8.00 grams? We're up at mass. We're up here at mass. So where do I want to go? Down to moles. So what am I using? 1 mole over the molar mass. I come back, I set up my conversion box. 1 mole of Fe2O3, and it's still important, folks, to write what we're dealing with. Okay, it's important to write the formula. And you said 159.6882 grams Fe2O3. Correct? So, when I do my math, what am I going to do? What am I going to do? Okay, first of all, do I get something to cancel? Grams in the numerator here. Grams of iron 3 oxide denominator. Yes, I do. So, I'm going to take the 8.0 and I'm going to multiply by 1. Do I need to do that, though? And then what am I going to do? Divide. So, I take the 8.0 and divide it by 159.6882, and it gives me a value. How many significant digits do I need? 3. So, as I look at my value, I'm going to have 0.05. And what's my label going to be? Mole of Fe2O3. Once I've got my answer, just so I make it easy for Mr. Braun to find it, I am going to put a square around it. We good? We come up with that so far? All right, our next example is, what is the mass of 4.87 moles of disulfur chloride? So Once again, I go to what was given to me. What was given to me? In my problem, I can see 4.87 moles of disulfur dichloride. What is disulfur dichloride? S2, what? Cl2. Now, in order to do this, where am I at? Where am I starting on my flux capacitor? Moles, and I want to go to what? Mass. So I am right here at moles. I want to go to mass, so I'm using the molar mass over 1 mole. Well, you need to take a second here and calculate the molar mass of disulfur dichloride. Then, Chloe, I saw your hand first. What is the molar mass of disulfur dichloride? 135.036 grams per mole, correct? So, what do I need to do? I need a conversion box, right? What goes on top? What goes on bottom? Don't just yell at me. Let me see a hand so I don't have everybody saying it at once. What goes on the top? Shelby? The mass, which was 135.036 grams S2Cl2. Always write your labels. You're going to try to get lazy. There's a reason we write labels. You're going to understand it in stoichiometry. Always write your labels. What goes on bottom? 1 mole of what? S2Cl2. Do I get something to cancel? Well, I have a mole here. I have a mole here. What's my label left? What's my label left over? Grams of S2Cl2. So what am I going to do? I'm going to take 4.87 and multiply it by 135.036. How many significant digits? 3 significant digits. So I'm going to have 658 grams. I could. The question is, would I put a decimal point after it or not? I could put a decimal point after the 8. It's not necessary because I'm reading that as 3 significant figures. Thumbs up? What I would like for you to do is, I would like for you to write down this question, and after you're done writing down this question, find the molar mass of sodium acetate. So write down the example, then find the molar mass of sodium acetate. All right, who wants to give me the molar mass of sodium acetate? Chris? 82.03379. Excellent. Now, start with, correct? Let's go. I want you to tell me, what do they want me to find? Atoms of hydrogen, right? So, let's go back to our flux capacitor. Where am I starting at? Now, I'm going to walk you through this to see if you can do it. Because this is one of the toughest ones we'll get. Okay? Where are we starting at? Mass, right up here. Correct? What do I want to go to? Atoms of the hydrogen. Well, once again, just something to think about. Okay? Something to think about. Am I going apples to apples? No. Okay? Remember that for a little bit later. I'm not dealing with apples to apples there, am I? So I'm starting at mass. The very first thing I need to do is follow this way to moles. Alright? So as I do that, I use my molar mass that Chris just gave me, which was 82.03379 grams of sodium acetate. That's 1 mole. Do I get a cancellation? Grams, grams, yes I do. So what I'm going to do is I'm going to take this number that it equals to, and I'm going to bring it down over here because I've got to do another part of this. So what I'm going to do is I'm going to take the 5.49 grams, and I'm going to divide that by the molar mass. And I get a value. Now, I get a value that's a big, long number. I'm going to round it, but I'm going to leave that number in my calculator because that exact number, all that big, long stuff, is what I'm going to use. But I'm going to round it right there. And that is going to be moles of sodium acetate. So now I've converted that to moles, haven't I? Did I want moles? No. I've got another step to do. Okay? So, I need to take that from moles now to representative particles. Now, what is the label going to be in representative particles? It's going to be what? Formula units of sodium acetate, right? What am I going to have to do then? Then I'm going to have to convert that into atoms hydrogen, right? But that's the stuff you were doing yesterday, correct? Correct? Okay, what I would like for you to do is go ahead and do that. Convert that to formula units, then convert that to atoms. Once you've done that, I'll work it up here on the board, and we'll check your work. All right, let's roll with this here. Let me go back. Now, I need to convert this into formula units of sodium acetate. So I'm going to set up my conversion box again. I know that 1 mole of sodium acetate That's formula units there. I get a cancel of my moles here. So, my value is going to be labeled formula units of NaC2H3O2. And when I do the math, I'm going to take, remember that big long number I told you to save in your calculator? I'm going to multiply that by Avogadro's number. And I come up with 4.0314 times 10 to the 22nd. Now remember not to forget the times 10 to the 22nd at the back end of your number, right, Connor? Because it does change it. Now, are we done? Why aren't we done? We have to change this now into atoms. So I need a little more space. I'm going to extend my page down a little bit. Now, I've got to extend or convert this into atoms. So I'm going to take the 4.0314 times 10 22nd formula units of sodium acetate. And I know that if I have that, I know that one formula unit of NaC2H3O2 has how many atoms of hydrogen? 3 atoms of hydrogen. Do I get a cancellation? My formula units right here. Cancels. So what's my final label? Atoms of hydrogen. Is that what I want to define? Absolutely. So what am I going to do? I'm going to take my number that I just got, the 4.03. There should be a 0 in there too. Okay. That's a wrong number, but that's okay. There's a 0 in between the 1 and the 4 right here. But that's okay because I still got it in my calculator. I'm going to multiply that by 3. How many sig figs do I need? 3 from back at the original number given to me. So I come up with the answer of 1.21 times 10 to the 23rd. Box it. Mr. Braun knows where my answer is. Agree? Thumbs up? I'm telling you what, folks, that was a 3-stepper, right? That's one of the harder ones you're going to get with this stuff. So if you understand that and are giving me a thumbs up, you're ready to roll with this, aren't you? Okay. So,